Good morning, everyone. Today I wanted to offer a lesson sort of in person instead of me actually using my iPad to write with my little Apple Pencil on and have you just view my writing. I wanted to actually try to offer me in person, even though it's videotaped. It's kind of more one-on-one, like you're in the classroom here. So anyway, today we're going to be looking at lesson 100. We actually made it there, so that's really good news. And by the way, your lesson plans are uploaded, and you will notice that tomorrow I'm going to give you the review sheet. I'm going to go ahead and send that to you on Edmodo so you can begin that. But we're actually going to take time on Tuesday, tomorrow, to play I Have, Who Has. I talked to you about that a little bit last week on our Zoom call, just to give us a little break. We've made it to lesson 100. I feel very good about that. You guys have worked incredibly hard. I think you deserve a day where we can play a game. Now, tomorrow is going to count for attendance and for a grade. I'm going to give you a participation grade. So that's an easy 100 in the grade book. So you'll want to make sure to be there. Please be on time, because if you're not on time, then the game is kind of ruined for everyone else. So I need you to try really hard to be there on time. I'm going to be sending you the cards from the I Have, Who Has that are assigned to you. So you will need to pull those down as well. So anyway, we're going to take a little break tomorrow from the textbook, and then on Wednesday we'll pick back up on the review sheet and go over any questions that you have, taking time for that on our Zoom call. And then Thursday is going to be a test 19, and then Friday I'll have you guys pick up on lesson 101 for your homeschool day on Friday. Okay, so today let's go ahead and talk about lesson 100. So we're going to be talking about estimating square roots, and we're going to be talking about irrational numbers. So there's two things we're going to be covering today, but they do actually go nicely together. Let me just also let you know I'm in a kind of a smaller space in one of the rooms in my home. And so sometimes I may have to pop out a little bit so you can see the whole board. So if you don't see my face, I'll be back, but just realize that I've got to make sure that you guys can see what I'm doing up here. So let's go ahead and start by talking about perfect squares first of all. So what are some perfect squares? So a perfect square would be a number that I could take the square root of that gives me a number that is squared to get back up into that square root number. So for example, perfect squares include 1, 4, 9, so that's 1, 2, 3, 16, 25, 36, 49, and this just goes on and on forever. So I put my little dots over here, the ellipsis, to indicate that my perfect squares continue on and on. Okay, but the square root of 1 would be 1. So if I put little square root signs over all of these, they give us a counting number. Okay, so it goes on and on and on. Square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. So these go on and on and on. So that means that these numbers I listed up here are called perfect squares. Okay, but what happens when I have a number, a square root, that's in between two perfect squares? For example, let's say I want to find what the square root of 29 is. Well, the square root of 29 is not a perfect square. I can't think of any number that when I square it would give me 29. So I know that it's somewhere in between the square root of 25 and the square root of 36. So think about this. So the square root of 25 is 5, and the square root of 36 is 6. So we know that the square root of 29 is somewhere in between 5 and 6. We have to find out what that is. So how can we do this? We're going to talk about that in just a minute. But on a number line, let me show you where it is. In our textbook, in this part, they don't actually have us, they're not going to have me show, I'm not going to show you exactly how we find out what the square root of 29 is, but I'm going to show you, whoops, kind of where it is here. Can't seem to do two things at once here tonight for some reason. Okay, so I've got my number line out here. So it's in between 5 and 6 somewhere, and the square, here's a half mark. The square root of 29 ends up being approximately 5. These little squiggly lines mean approximately 5.39. So it's, and this is 5.5 right here. That's halfway in between. So it's about right here. That's the square root of 29. Okay, and we'll talk a little bit about that in just a moment. You have an example in your notes there, and I want you to go ahead and look at example 1. We're going to figure out between which two consecutive whole numbers the square root of 200 is. So let's talk about that. So the square root of 200 is in between which two consecutive numbers? Square root, this is example 1. We're looking at the square root of 200, and we want to know what two integers or whole numbers, how do they word that on there? Whole numbers. The square root of 200 is in between. So let's think about this. I have to think of a number that I know is a perfect square, a large number that gets me close to the square root of 200. Okay, some of you might know your multiplication tables well, and that's great because you might be able to think larger than this, but I'm going to start a little bit small for those who struggle a little bit with some of the higher multiplication facts. So I know that the square root of 100 is 10. Let me think, what is next? The square root of 121 is 11. But look, I've got to get all the way up to the square root of 200. So let's just do the ones we know. The next one would be the square root of 144 because that's 12. Notice what I'm doing, 10, 11, 12. The square root of 13 is, 13 is the square root of 169. And that's about where I end. So 14 times 14. So I have to think about this now. So what is next? So 14 squared is going to give me what goes inside here. So I'm going to go off to the side here and do what is 14 times 14? 16, 56, 0, 4, 1. Okay, so that's 196. Okay, so in your notes, you can write all this down as I am if you would like to, or you can start at whichever one you knew was the highest one that you could do in your head. For me, it would have been right here at 13. Okay, if yours was 11 times 11 is 121, so you could start with the square root of 121 in your notes. You could start there. The reason I say that is this is a lot of space, so you do need to write small if you want to include all of these. And in fact, when you see my notes written on Edmodo, you are going to see all of these written across. Unfortunately, I didn't leave myself enough room to do the next one. I'm going to squeeze it in right here. So I don't know what goes under here, but this has to be 15 times 15. Whatever goes in there, this one here was 14 times 14, right? And I got 196. So let's see, what's 15 times 15? 25. 75, 0, 5, 1. And I get 225. So this would be 225. Okay, so we just discovered the square root of 200 is going to go right in between there somewhere. So I'm going to erase all of this off of the board to make some room for what we're about to do. I want to actually show the square root of 200, the square root of 196, and the square root of 225 here. We said this was 14. This is 15, and the square root of 200 fits in between 14 and 15 somewhere. So the square root of 200, now that's not going to be, it's not going to give us a perfect square. So we're not going to worry about figuring out what that one is at this moment. But we just wanted to try to figure out where in fact it's going to fit in between. So it's going to go in between these two consecutive numbers, somewhere in between 14 and 15. So in your notes, as long as you have this part right here written, even if you had all these other ones that we were doing over here, that's okay. Okay, but this is what I want you to box off. Okay, so I wanted you to just kind of see how we discover, we find where it needs to be placed, but sometimes we don't know those numbers off of the top of our head, so we have to do a little calculating to figure out what comes next after the ones that we stop at. Okay, so that's where we find that the square root of 200 is somewhere in between 14 and 15. Okay, so the next thing, we are going to look at this square root of 29. And this is not going to go in your notes. I'm just going to talk to you about this, but you do need to kind of watch how I conclude my answer here. Okay, so we said that the square root of 29 was somewhere between 5 and 6. Okay, we talked about that in the very beginning. I showed it to you on a number line as well. If I wanted to refine this number by finding a decimal or a fraction for this, this is where it gets a little bit challenging. So I'm going to figure out a closer number, like what is it? It's 5 point something, right? So if it's in between 5 and 6, this is going to be 5 point something. How do I figure out what that is? So remember, this 6, let me write this down here, was actually the square root of 36, right? I'm going to put the squares up here for you. And this was 5. This was the square root of 25, okay? This is going to be 5 point something because it's in between 5 and 6, okay? Now remember that, how do we know that's 6? Because that 6 times 6 is what makes 36. That means whatever this number is, let's just say it's 5.2. What that means is I'm going to have to multiply 5.2 times 5.2, and it should get me close to the square root of 29. This is not a perfect square, so we're not going to get an exact number. We are going to get something that's close. So I'm going to go ahead, I'm not going to start with 5.2. I'm actually going to start with 5.3. Just to see where that lands me. So I get 9, I get 15, 0, 15, 25, 26, 20, 10, 7, 9, 10, 6, 7, 8. Okay, so I get 28.09. That's pretty close. It's a little too small. So I'm going to try 5.4. I'm going to go up here and just try that. Let's see if that gets us a little bit closer to 29. So I get 16, 20, 21, 0, 20, 25, 27, 6, 1, 9, 29.16. Ah, that pushes it over, doesn't it? So this one's too big. There's nothing else to try in between those two, so this one is going to be the closest one. So it's about 5.3 is the number that we would choose. That's the number that comes in between 5 and 6 that represents the square root of 29. But just keep in mind, it's really approximately. Those little squiggle lines mean approximately. So really, what we do is we say the square root of 29 to make it more exact. We just say the square root of 29 is in between 5 and 6. Because it's not really 5.3, right? That was an approximation. So we just use it in its original form to state that this square root is in between the consecutive numbers 5 and 6. Okay, so really it's just a little experimenting. Okay, so what if I used a calculator for this actually? What did I say this was? 5.3, right? That's pretty close. If I put this in a calculator, and my calculator's way over there, so thankfully I did this a little bit ahead of time. If I use a calculator to find the square root, this is what it comes up with. And actually, it goes off my screen. So it's 5.3, 8, 5, 1, 6, 4, blah, 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 blah. So it's a never-ending number. And when I see a never-ending number like that, and it's not repeating, if it was repeating 5.3 with a repeating bar, the 3's repeat, that's okay. Then I can mention it as 5.3. But this is a number that this decimal number part of it goes on and on for a very long time. So, and perhaps forever. So we call this an irrational number. which is the second part of our lesson today. So up at the top of your notes there, I want you to fill in, there's some blanks up there for you to fill in. This is the way an irrational number should read. Let me read this to you, and you can fill this in. Irrational numbers cannot be expressed as a ratio of two integers. Their decimal expansions are non-ending and non-repeating. Okay, so that's what I was trying to explain here. This goes indefinitely. And when you have a decimal number that does not end like that, that is considered an irrational number. Okay, we talked about rational numbers back when we talked about number families. So when we talked about those rational numbers, we didn't make mention of irrational numbers because those weren't included in that lesson. But here we're talking about what those irrational numbers are. Let me say it again, and you can also see this in the notes that are going to be posted for you. Irrational numbers cannot be expressed as a ratio. I'm going to write down the words that you have to fill in case you didn't get those. As a ratio of two integers. And actually in my notes, I handwrote them in because this was an afterthought. So I'm trying to remember which ones are left as a blank here. Their decimal expansions are non-ending. I think you have to fill this part in. And non-repeating. Irrational numbers. Okay. I'm going to show you where you might see the square root of 29 come up on a triangle's measurement for one of its sides. So I'm going to draw here. This is just for you to watch. This is pretty cool though, because you guys, we talked about the Pythagorean theorem the other day. We talked about how we can use the Pythagorean theorem to figure out a missing side length. Okay, we talked about this is a leg, and this is the hypotenuse. And in this case, I have a right triangle that does not have a measurement for the hypotenuse. So I want to use the Pythagorean theorem to figure out what that is. So watch how this works. We said it was a squared plus b squared equals c squared. These represent the legs, and c represents the hypotenuse. So I'm going to take my first leg and square it, and add to that my second leg squared, and it should give me my hypotenuse squared. So what do I have here? So I have 4 plus 25 equals, how do I want to write this for you? Equals c squared. So I'm going to leave it like this for just a second. I'm going to come back over here. I'm going to write this right up here. So 4 plus 25 is actually 29 equals c squared. So how do I figure that out? It's the square root of 29. Because remember, guys, if this was 25, I don't want you to get lost here. If this was 25, as an example, if this was 25, we would know that c would be 5, right? Because it's 5 squared. But since 29 doesn't have it's not a perfect square, we would just say that c is the square root of 29. Okay, so the side length here is the square root of 29. And as I mentioned earlier, the square root of 29, we can actually say that that is an exact value, even though when I put it in the calculator, I get 5.3, and all those extra numbers. But the square root of 29 is actually considered an exact value. So if we leave it as the square root of 29, we're good to go. Okay, let's look at some other examples of irrational numbers. I'm just going to write them right over here on the left-hand side. So examples of other irrational numbers are pi. That would be one. Because think about pi, it's 3.14 and all those extra numbers that go on and on forever. So that's an irrational number because it's non-ending. The square root of 6 is not a perfect square. So there we have that. The square root of 5, the square root of 3, any of those that are not perfect squares. So any of those work as irrational numbers. Okay, those are examples, just a few. There are more. squares that we can, that are not perfect squares, numbers that we can list that are not perfect squares. Okay, so keep in mind they cannot be expressed as a ratio of two integers. Remember, rational numbers were numbers that could be expressed as a ratio. So we could have 2/5. Remember? What else could we have done? Did I write some down for you? Back in an old lesson where we talked about number families, we listed a bunch. They could be improper fractions. They could be decimals, for example, 0.125, because that can be written as a ratio as 1/8. Right now I'm kind of writing all over the board here. I'm going to erase this and make some sense of this. But remember, rational numbers can be written as integers, as a ratio of two integers, whereas irrational cannot be, okay? They're pi or any non-perfect square are considered irrational numbers. There's one more term that is brought up in today's lesson, real numbers. And under the category of real numbers are both rational numbers, it just means that we do use them, and irrational numbers. They do have a value to them, and so they are included as real numbers. Okay? All right. Example 2, let's take a look there. Show the appropriate location of the points representing the following real numbers. Okay, so these are numbers that actually do have a value. We use them just like you saw on the hypotenuse a moment ago. We said that the length of that side was the square root of 29. That is an exact value when you write it as the square root of 29. So on this one, we're going to describe these as rational or irrational once we get them on a number line. So you have a part of a number line there written for you. I'm going to have you fill in the numbers on that though. First of all, let me write down the ones that we're going to be looking at. So this is example 2, and we're looking at pi. We're looking for the square root of 2 to be placed, 2.3 with the repeating bar there, and -1/2. On your number line, let's go ahead and fill that in. Mine's not all that great. It's not that straight. I'm going to have you start at -1, and then I put in your big lines here to go up through 4. 0, 1, 2, 3, 4. And then in between each of these, just put a little half mark here because we're going to need that. Okay? So your number line should look like that. So let's place the ones that we can see. I think we can see where -1/2 goes. So here's 0, here's -1. So -1/2 goes right in between there. That's -1/2. Okay, let's place them and then we'll come back to say whether or not they're rational or irrational numbers. Okay, now let's see if we can place, probably the one that might make the most sense would be, let's look at 2.3 repeating. So it's 2.3333 forever, right? But 2.3 is not quite 2.5, which is right here. So it's going to be a little bit before that. It's not quite 2.4, so I'd say it's about right there. 2.3. Next one I would do is pi. Pi is, remember, 3.14. So we're going to go over to 3. It's not going to be quite 3.2, but it's going to be a little bit bigger than 3.1. So it's probably going to be like right there. And that's pi. And then the last one we're going to look at is the square root of 2. So I have to think about where the square root of 2 actually is. So how do I do that? So I'm going to grab a different color pen so it doesn't get so mishmashed when you're looking here. I'm going to write down where this falls in between. So remember, it's going to be in between the square root of 1. We've got the square root of 2 and the square root of 3. I'm sorry, square root of 4. because square root of 3 is not a perfect square. So we're listing down perfect squares that the square root of 2 would fall in between. So the square root of 1 is 1. The square root of 4 is 2. So the square root of 2 falls in between 1 and 2 somewhere. So how do I figure out what the value of the square root of 2 is close to? So let's do a little bit of work here. I guess I could start with maybe, let's start with 1.5. Let's just say 1.5. So on your papers, you can look at 1.5 times 1.5. Let's see what that gets us close to. 25,7,051. Did we already do this one a minute ago? I think we did. So that's 2.25. That's a little bit big, isn't it? If it's going to be in between 1 and 2, 2.25 is too big. So we can't use 1.5. That's too big. So let's go over here and try, let's back up. Let's do 1.4 times 1.4. Let's see what we get with that. I'm going to spare you all the gory details on that one and just tell you that it comes to 1.96. Okay, that is too small, but it's going to be what goes closest, isn't it? So 1.4 is the approximate value of the square root of 2. That's the closest that we come to. 1.4 times 1.4 will get us close to 2. Gets us to 1.96. Okay, so we know now that the approximate value of the square root of 2 is 1.4. So let's find where that would go. So 1.5 is here, so it's going to be right about here, square root of 2. Okay, I'm going to erase this off here. I think you probably should have written this down, at least write this down there so you can see what we, how we determined the two consecutive numbers that the square root of 2's value was going to fall in between. If I put this in the calculator, because I tried it, the square root of 2 gives you 1.41 and then a lot more digits. So there again, it's an irrational number because they go on and on forever. So the square root of 2, let me write this in another color pen here. This can be 1.4. I'm going to take my red pen and let's see if we can determine what is rational and what is irrational. Okay, so we talked about anything that's not a perfect square is irrational. We've already addressed that pi is irrational because 3.14 is not the end of pi. Remember, it goes on and on forever. So that is irrational. It's non-ending. Non-repeating. Okay, this one is repeating. Okay, so this doesn't fit the definition of the irrational numbers. This is rational. And then any ratio that we can write is also rational. It can be negative, it's okay. Positive and negative ratios are considered rational numbers. That concludes the entire lesson for today. I don't think in the lesson when you come upon one of these problems, I don't think you're gonna have to do a ton of figuring like we did today. This was a great lesson though for you to see how we determine non-perfect square numbers. So I hope that some of this made sense to you. If you do come across the problem and you get confused and you need help, we can go over it when we meet on our Zoom call. Okay guys, that concludes the lesson. Please be sure that lesson 99 gets turned in Monday by 3 p.m. This lesson 100 will be due, I forget what I put on the lesson plan. We're not going to go over it on Tuesday, so it should be due on Wednesday by 3 o'clock. And then our review sheet that we're going to be doing will be due by 3 o'clock p.m. on Thursday, which is also test day. So it will be to your benefit, though, to have it done before 3 o'clock because we're going to go over those problems to get you ready for the test for Thursday. So hopefully you'll have those done and you can submit those to me even before 3 o'clock on Thursday. All right, guys, thanks for watching, and I will see you on our Zoom call. Have a great afternoon.